Hey guys, welcome to another 5 minutes of eats. Today I'm going to show you the eats annotations for debugging and documenting threading policies. So these annotations kind of fall in line with those in JSR 305. You guys may have seen them, such as thread safe or not thread safe and so on. So these new eats annotations, you can apply to your methods to kind of document your threading policies, and eats will also knows how to look at those annotations, see what they mean, and make sure your program is adhering to the restrictions specified in by the annotation. So the annotations I'll be showing you today are concurrent accesses, not on thread, not on threads, on thread, and on threads. And this one will come in a later video. So let's look at not on thread first. What not on thread lets you do is annotate a method and say what thread it shouldn't be run on. So let's say we have some method component updater that changes the background of a J component. And as you all know, you shouldn't mess with you're not allowed to modify any swing components off the AWT event dispatch thread. So to enforce that, we can use eats to document or enforce. We can use eats to say on thread AWT event. And eats will look, and if this matches a prefix of any thread that comes in here, it'll say it's okay. If it doesn't, it'll throw an error. So this way, developers with C component updater, they know they're only supposed to call it from this thread. And if you run your application with eats, at runtime, eats will tell you if this is ever violated, this on thread restriction. So let's go ahead and violate that restriction and see what happens. So here we're calling component updater on a text field in the main thread. So we should obviously get an error because we specify this should only be run on the AWT event thread. And here we go. On thread had access from thread main, expected thread AWT event. And then you get a nice stack trace, and you see which method had its rule violated, which would be component updater in demo.java, which was called from demo line 33. So that's on thread. Not on thread is kind of similar. And you say, oh, I don't want this to be run on the event dispatch thread because, say, it's some long running task. You don't want to lock up your UI, so you document it, tell all the developers, don't run this on the event dispatch thread. Just put sleep in there to show it's a long running task. Go ahead and call it from, I'll make a call to it. Let's put that call on the event dispatch thread. Alright, so here we are going to be invoking long running task on the event dispatch thread, and we said it shouldn't be run on that thread. Go ahead and run it. You see that long running task was run on thread AWT event queue, which it shouldn't have been. And we get our stack trace to see the offender, which obviously is just invoke, just the invoke later. So those are those two. They're pretty simple, but they can help. They have plural counterparts, not on threads, and you can give that AWT event main if you don't want it running main either. Go ahead and import that. So then we can see it's not supposed to be run on the event queue, and it's not supposed to be run on main. So we'll go ahead and run it on main to show you that it doesn't like that either. So you get the error, it was run on thread main. The errors that each throws does not stop your program execution. These aren't actual exceptions, they're just stack traces that are grabbed and printed to the console. So, or whatever logger you choose to use. Eats uses commons logging, or will be soon. So yeah, that's that. Let me show you my favorite one. I'm sure I'm over 5 minutes now, but let me show you my favorite other annotation. It's concurrent accesses. This lets you specify how many threads are allowed to be in a executing within one method at a given time. So we say concurrency level is 1 for long-running non-thread safe task, right? We say, hey, we only ever want one thread in here. I should probably have left that sleep in there, but let's put it back in. So we need a sleep so we have long enough for all of our threads to get in there. So let's make 2 new threads. That are both going to give our non-thread safe method a call. Alright, actually let's just run it from one thread first to show you that it works. Let me see, sys out. Say what thread names are entering. Alright, what threads are exiting, just so we know what's going on. And let's give it a run. Thread 0 entered, thread 0 exited, no errors because only one thread ever was in there at a time. But if we uncomment this, run it again, we get nice stack traces because we had a violation. Non-thread safe task had 2 concurrent accesses instead of 1, and it gives you stack trace of thread 0, which accessed it, and thread 1. So, that's all I have for the debugging, threading, or concurrent debug annotations and eats. Later on, I'll show you the caching annotation, where you can just annotate a method with @cache, the cache type, and the reference type, and how it'll cache the results of method calls and so on and so forth. But anyways, that's for next time. Hope you guys enjoyed the video, and look forward to seeing you again.